Hi all, today we are going to see about the lecture series on Unit 2, Unit 4, 2 in Design and Analysis of Algorithm subject. So the Unit 2 is about brute force method and divide and conquer. What do you mean by brute force method is exploring all the possibilities to solve the problem, and divide and conquer means we are going to divide the problems into sub-problems to solve the sub-problems and then combine or merge the solution to reach out the. So hi all, now we are going to see about the next technique, which is divide and conquer design technique in unit 2. Here in divide and conquer technique, as I previously said, we are going to divide the problem which is of size n into sub problems of size n by 2. Here I am considering n by 2. You can divide on the requirement. Okay, so I'm dividing the problem into sub problems and finding the solution to that sub problems, and I'm going to reach out the original solution by combining the solutions of the sub problem. So this is the design and conquer design technique. Hi, the next topic we are going to see in divide and conquer is multiplication of large integers. How to do multiplication of large integers in divide and conquer strategy using divide and conquer strategy. So here we are going to decrease the number of multiplications. Okay, so here we are going to decrease the number of multiplications at the expense of a slight increase in number of additions. Here we are not going to decrease the total processing time. Here I'm going to decrease only the number of multiplications at the expense of a slight increase in number of additions. I'm going to increase the count of addition and I'm going to decrease the count of multiplication process we are doing in the multiplication of large integers. So in multiplication of large integers, consider this example 23 and 14. I am taking two integers. The integers are 23 and 14. Now my n is equal to 2. So in 23 I am considering 2 as a0 and 3 as a1. In 14 my b0 is 1 and b1 is 4. So n square is equal to 4. 4 multiplication I am going to do. So okay, so 23 is equal to 2 into 10 power 1 plus 3 into 10 power 0. So total I am getting 23. Okay, in 14 1 into 10 power 1 plus 4 into 10 power 0. Okay, it is 14. Okay, 23 into 14. So 2 into 10 power 1 plus 3 into 10 power 0 into 1 into 10 power 1 plus 4 into 10 power 0. Here it is, so I'm having 10 power 1. I'm adding these two, 2 into 1 into 10 square. So I'm using this formula. So 2 plus 4 plus 3 minus 1 into 10 power 1 into 3 into 4 plus 10 power 0, which is 8 plus 3 is equal to 11. So after further processing I'm getting the answer as 11. Okay, so we are going to use this formula. C is equal to a into b, which is equal to c2 10 square plus c1 10 power 1 plus c0. So c2 is equal to 2 into 1, which is equal to a0 into b0. c0 is equal to 3 into 4, which is equal to a1 into b1. c1 is equal to a0 plus a1 into b0 plus b1 minus c2 plus c0. So c is equal to a into b, which is equal to c2 10 power n plus c1 10 power n by 2 plus c0. So this is the analysis of the multiplication of larger integers. So m of n is equal to 3 m of n by 2 for n greater than 1. So n is equal to 2 power k is equal to log base to n. So m of 2 power k is equal to 3 into m of 2 power k divided by 2 power 1. So which is equal to 3m 2 power k minus 1. So 3 into 3m 2 power k minus 2. So 3 square. Finally on solving this I am getting n power 1.58. So performed well over integers 600 digits long. So the final equation becomes a power log bc is equal to c power log base be a. So this is the final outcome of the multiplication large integers. So when we compare with other normal multiplication, here I'm going to reduce only the number of multiplication done and I'm going to increase that with the addition. So when compared with addition and multiplication, addition is somewhat easier for the human beings to do. So I'm going to reduce the number of multiplications, I'm going to increase the number of addition and solve the problem. So this is the ultimate aim of this multiplication of larger